chapter E, infinite series. And the first series we're going to consider is the geometric series. Now this series here can be written as a term. You could pick a constant. I'm going to pick 1 to start with, and then add a factor that we're going to be multiplying by consistently, term by term. So I'm going to pick r for the factor. R times 1 is r, and then r times r is r squared, and then r cubed, and on to some r to the nth power. And we'll call that the sum to the nth term. So here you would say, well, technically I have n terms plus 1. So if I want to write this as a series, I would say let k start at 0 and then go to n, r to the kth power, r to the kth power. So here when k is 0, I would have r to the 0, which would be 1. Then when k is 1, I would have my r, and then when k is 2, I would have r squared, and so on like that. So we'll call that the sum when there's n plus 1 terms, but I'll label that as s sub n, which means we go from 1 out to r to the nth power. Now to find this sum, here's the trick. We multiply both sides by r. So let me go ahead and write this out as 1 plus r squared plus r cubed plus r to the n. So now if I multiply both sides by r, I would have r times Sn is equal to r times 1 is r, then r squared, r cubed. I'd have 1 extra power as we go, and this would end up with an r to the n plus 1. So now what I'm going to do is subtract this left side from this left side and this right side from this right side. So when I do that, I'll have s sub n minus r s sub n. And now over here, you can see this r will cancel that r. This r squared will cancel that, and that'll cancel here. And I'm going to be left over with 1 extra term here, but I'll have the 1 and then minus r to the n plus 1, because there'll be 1 extra piece here. You could say right here before we got there was an r to the n here, and then plus this one. So that r to the n cancel that r to the n. All the lower powers of r, we cancel all these, leaving the 1 by itself and the r to the nth plus 1 by itself. So now what we do is we factor out 1 minus r, and that's 1 minus r to the n plus 1, and then we divide. So we have this cool formula which has a subtraction in the numerator and a subtraction in the denominator. It's kind of a nice little formula. So that would be the sum of the terms from 1 out to r to the nth power. Now, we're going to be dealing with series that are infinite, that keep going forever. So I would like to use this as an example to see what happens if we take the limit as n goes to infinity. So they'll have here to the right an infinite amount of terms. So we're going to call that sum just S, or you could, if you want, put an infinity sign for the n, and that would be equal to the limit as here n goes to infinity of 1 minus r n plus 1 over 1 minus r. Now, the question that we're going to be raising in our course is often we deal in physics with a series and we want to know if it's going to converge or not. A series converges when the sum is finite. Now here, if r should be less than 1, and here this r I'm taking to be a positive quantity, then you can see that as r squared, r cubed, those numbers keep getting smaller and smaller. And the limit, as n goes to infinity, of this first part, that won't change. But the second part, as n goes to infinity, you have something less than 1, that's going to vanish. So the answer for the sum is going to be 1 over 1 minus r. Now, if we take a specific case, for example, r being equal to 1/2, then the sum would become 1 over 1 minus 1/2, which is 1 over 1/2, which is 2. Now, there's a real nice way to see this in a visual sense. Let me write it out for this S, going back to our first principles here, up in here, where you have 1 plus 1/2 plus, then you have a squared, 1/4, and then you have a cube. In other words, you basically multiply by 1/2 each time, 1/8 plus 1/16 plus dot, 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 like that going out. I would like to show you that this sum, which we know needs to be 1 to get this 2, I'm going to show you that by a neat little square. So we're going to take a square here, and for this square, I'm going to divide the area in half. So this would be 1/2 the area of the square. And you can consider the square the total area. The total area here is equal to 1. So this is then 1/2. And then watch this. If I divide this other part, which is 1/2 by 1/2, this is then 1/4. And then I'm going to divide this one going with the vertical line. So that this is 1/8. Then I'll divide this one. I'm alternating in vertical versus horizontal. This would be 1/16. And then if I come up in here, I would go like that. And that would be 1 over 32. Then if I slice this way, I'd have 1 over 64. And if I just keep doing this, I'll have all these terms, and that's going to be equal to the total area, which is 1. So we take that 1 plus that 1, and we get then for the sum, 1 plus 1 is 2, with a nice visualization of that relationship. So this is the introduction. We'll be looking at other kinds of series, and then basically we want to really have a test to see if a series will converge or not. That's very important for physics. When we solve equations and get solutions with infinite series, we want to make sure that they converge so that they don't blow up with an infinity somewhere. And therefore, we would have, with the finite case, something that is realistic and applicable to physics.